Hello students, good morning. Today we are going to discuss the continuation of the previous video, addressing mode 2. Okay, previous we have 5 modes of addressings are there. So in that, mode 1 is shift operands, mode 2 is load and store instructions, which is of byte and word. Now addressing mode 3, which is of signed byte as well as signed word also it is there, signed half word is there. So next is multiple store instructions. So today's class, today we are going to discuss addressing mode 2, continuation of the previous video. So in this class we will discuss about unsigned byte access. So in the previous video we known about 32-bit. Now in this video we are learning about 8-bit addressing mode 2 access. So in this, that what is that, some rules and regulations will be followed from the previous videos. Now we'll see into that, have a look into it. Now in the addressing mode 2, LDR and store instructions are there. The W bit, which is called as auto increment and decrement addressing mode. What is that auto increment and decrement addressing mode? If W is 1, the base register Rn will be modified back if it is indexed with NOT. The NOT operator, if it is used automatically, it will update the base register value. So here two steps will be there. First of all, whenever W equal to 1, either it is 0, all these cases, here it is following two steps. What is the two step? Base register is added with the offset first. Next, the content of the memory, which is pointed by the base register Rn, is loaded into the destination register. Okay, so this is that whenever the W equal to 0 or 1, whatever the case. So first of all, the base register is added with the offset. Now the content of that is pointed by the base register will be loading into the destination register. Now whenever W equal to 1, the base register will be updated. Whenever W equal to 0, the base register will not be modified after adding the offset. That's what the W is saying here. Now what is it if it is a post indexed? In the previous videos what we learned, here we have given an example. LDR, R5, R1, R7, ASL stands for arithmetic shift left by 2 times. Which register contains R7 contents will be arithmetic shift left by 2 times. So what is the value if you are giving that? What is the R7 value in the previous videos? It is 1. 1 is arithmetic shifted left by 2 times, in the sense the value will become 4. Okay. So first of all, here whenever the post indexed, here also it is following two steps. First of all, what is the first step? The base register Rn content will be loaded into the here the post indexed, in the sense here it is following two steps. What is the first step? The base register, which is Rn. Here what is the base register is R1. The R1 content of, here R1 is pointing to the base register here. So the content of R1, which is pointed by a memory location, is loading into the R5. So that's what the first step. The base register R1 content of that base register is loaded into the R5. What is the second step? The base register is updated with the offset value in the above. Okay, R7 will arithmetic shifted left by 2 times. Sorry, here I forgot to write shifted left by 2 times. What is the value of this? R7 will become 4. But the R7 value will not be modified here. It will not be updated. The value of this, it is here, it is R7 will be shifted, arithmetic shifted left by 2 times. What is the value of that one? 4. So the 4 will be added to the R1. So according to that, what is the value will be there? It is updated in the base register. Okay, so these are the two steps will be there. That's what we are not using any NOT operator in the post indexed here. Okay, so here what is that? Here always write back, the modified base is not required here. That is has been specified here. Okay, yeah. So what is this? Is nothing but always write back the modified base. The modified base will be there without using the NOT operator at the end. So the write back bit is redundant. What is the write back bit? It is called as NOT operator. The W is always 0, because in the post indexed case we are not specifying auto increment or auto decrement. Automatically it will happen here. So the W is always 0 during the post indexed. Okay. So what is the next rule that we have to follow here? It is the W bit is used in a post-indexed data transfer only in privileged mode, which will be explained later. Actually, this will be explained later. So what is this? Is nothing but the processor contains that memory management unit. A part of the processor which is occupied in a memory management unit is called as there. It is there, which is inbuilt of the CPU. It will take care about what the memory operations it is going to happen in the processor, so that the speed of the processor will be synchronized with the other memories. So the MMU will be taking care of that one. So actually the program, the memory will be divided into two parts. One is called as user data, another one is called as operating system. So here the memory management unit will be accessing the user data. Will be accessing the user data by the OS. It is used by the OS to access the user data with the help of the MMU. So it is not accessing the OS. It is used by the OS. So none of the any malicious nodes or any malicious things will not be accessed with the operating system. So operating system is taking care of that to accessing the user data with that CPU. CPU is nothing but MMU. It is interacting to store or to load the data. So directly processor is not interacting. Here MMU is interacting with the user program or user data which is there in the OS. So the OS will take care of. This is called as post-indexed data transfer in privileged mode. The mode we are calling it as here, it is called as privileged mode. So in furtherly we will explain later on here. Okay, now let us go into the next slide here. We'll see an example of that unsigned byte access. In the previous video we learned about word access. Word is nothing but 32. I already have discussed it, that one. ARM processor is having three data formats. First format is word, which is called as 32. Next one is half word, which is called as 16-bit. Another one is byte format, which is nothing but 8 bits. Okay, here we are going to see about the ARM mode 2, which is explaining about 32-bit, which is called as word. Another one is called as byte access, unsigned byte access. Here that examples we will look into it. Now in this, the ARM unsigned byte access, whatever it is there, while it is storing the data in the form of ARM is in little endian mode. Already we know what is the little endian mode. Even it supports big endian mode also. So the ARM processor, this is one of the characteristic of the ARM. How we are storing the data of ARM in memory, either in the little endian mode or in the big endian mode. Here we are taking an example. It is very easy to understand for the students. That's what we gave in the little endian mode. Okay. So now let us see an example. LDRB R5 gamma R2 hash 0x01. So what type of format here? It is nothing but this is called as pre-indexed without write. No write is there. If not operator will be there, then we will call it as W equal to 1, and this is called as pre-indexed mode. And here immediate data. So this is called as immediate pre-indexed with no write back. Okay, so the format is already we have seen in the previous cases. So if you want to, you just go back to the previous slides and just go into that. Okay, now LDRB stands for load the register of byte contents. Okay, first of all we have to evaluate this. So R2 it is pointing to 101C and comma 1. What is the offset here? It is nothing but 1D. So this is the offset here, EF. Okay, so here LDRB is nothing but it is loading the byte contents which is pointed by the base register. So what is that? It is called as, it is storing only this byte. That's what it is storing here. The rest of the values will be zeros. That's what 00 EF will be specified, and R2 will not be updated because what is this? Already we discussed, there is no write back. That's what, there is no change in the base register RN. The RN is nothing but R2. Okay, let us see in the one more example here. The load register byte of R5 with base register. The base register is R2. R2, what is the address here? 101C. And what is the immediate value? It has been given 03. So this is 0, this is 1, this is 2, this is 3. So what is the third offset here? The value it is AB. So the AB byte is loaded into the R5. The rest of the values will become zeros, and there is no updated here. Why? Because there is no not operator, write back is not given in the instruction itself. Okay, now let us, I think you are understanding this one. Let us move to the next slide. So in this slide also has been given, all these slides we discussed about that load only. Now this slide we will discuss about the store, STRB. STRB stands for store byte. So how it is operation is performing, storing in the sense storing the register content into the memory which is pointed by the base register. Repeating once again, store byte is nothing but storing the register contents into the memory location which is pointed by the base register R1. So what is R1 address here? 1018. So 1018 has been given. Now here the contents will be loaded. What is the R6 content here? It is 4. What is R6 content? It is 4. It is storing in the byte. It is not modifying all. It is modifying only the byte here. Which byte it is modifying? That is nothing but the first byte. So which is of 0 offset. So it is changing the contents of that first byte 1018 as 4. So after modification, what is the value here? It is 18 is nothing but 1, 2, 3, 4, 5, 6, 0, 4. The whole 32-bit content has been changed it as, the last byte is changed as 0, 4. Okay. So let us move to the next slide. I think you are understanding this thing. Now see in this STRB. See in the previous slide what is the value has been given? 0, 4. Which is of 18. The previous contents as it is not going to change because of STRB. B is changing that nothing but storing a byte content. The rest of the bytes will be remains in the same values. Now in this next example, add R1 comma immediate hash 0x01. So we are adding 01 to the R1 that will be updated in R1. So how we will write it as here? R1 equal to R1 plus the immediate data. What is immediate data? 0x01 will be added to the R1. What is R1 value? 18. So 18 plus 1 is equivalent to 1019. So that is the address has been given here R1. So what is the base address here? According to the previous instruction, the base address is being modified here. The contents of that will be loaded with the R6 contents. So it is storing the R6 contents with the R1 base register. What is the value of R1 here? 1019. So that's what is the value here? It is in the 0x1018 1 2 3 4. It is not modifying the rest of the bytes, either 0 byte, first, second byte, third byte. It is not modifying. It is modifying only the first byte 04. Okay. Now let us see that. I think understood. Okay, have a look into it. Add R1 equal to R1 plus 01. It is adding the immediate data to the R1. It is updating in the R1. The updated, because there is no write back here. In the previous instruction we are adding. That's what it is storing the R6 content into the R1 register. The R1 is base register. Okay. Let us move to the next slide. So what is the rules and regulations to be followed for addressing mode 2? So we are coming at the end of the addressing mode. Okay, so in this addressing mode, what is the rules and regulations to be followed while you are using the addressing mode 2? In the sense, write back must not be specified if R15 is specified as the base register. Usually R15 we will not use as a base register. If you are specifying, write back will not be used. Usually we will not use. If you are using R15 as a base register, the write back, especially in this not operator, should not be used. That is the first rule that we need to follow while if you are using R15 as a base register. So in the second point, which is telling about when using R15 as the base register, you must remember it contains an address 8 bytes on from the address of the current instruction. So while even though if you are using R15 as a base register, this is the rule that what we need to follow, the E offset. What is that? That 8 bytes from that current instruction, it will be pointing to the next 8 bytes. It is not pointing to the next 4 bytes. So if you are using R15 as a base register. Now, R15 must not be specified as the register offset. Why? That is the violating rule. You should not use R15 as a offset. And if you are using register as a base, you should not use write back. If you are using R15 as a offset, we should not use that R15 as a offset here. Okay, RM is not used as an offset, while M is equivalent to 15 we should not use. That is a violating rule. Now, while next last condition, when R15 is a source register, Okay, source register. RD of a registered store instruction. The stored value will be the address of instruction plus 12. This is a rule what we are following. Addressing mode 2. The first rule what it is telling here, it is called as, the rule it is, for the word and unsigned byte instruction, the immediate offset is 12-bit number. So according to this, while it is storing, the offset will be the source register, that stored value will be addressing up to instruction plus 12 will be given here, while it is especially using the store instruction. So these are the special conditions and rules to be followed when mode 2 is using, especially when R15 as a base register, and we should not use as an offset here. So okay, let us move to the next slide. Okay, so now addressing mode 3, the addressing mode 3 which is explaining about the half word and signed byte instructions, it is an 8-bit or 16-bit. Let us see into that with an examples what it is required for that. So addressing mode 3, half word signed byte operations. Now we'll see what is a pre-indexed format, what is the syntax. LDR load register, store register, condition, which is supporting all the conditions. H for half word, signed byte. RD is for destination register. RN as usual base register. Offset pre-indexed with the write back. So wherever the post-indexed form, LDR, STR, condition, which is supporting all the conditions, all the flags which will be there, but it is not updating the flags here, okay, because it is not data processing instructions. In this post indexed also, half word is nothing but 16-bit. Signed half word is nothing but the content will be signed negative value, negative byte 8-bit data. RD destination register, base register. Here post indexed is nothing but, here the square brackets will be included in the pre-indexed form, where in the post indexed form it will not be there. Here 2 steps. What is the 2 steps? First load or store, then increment, then the base will be added to the offset. Here first base will be added to the offset, then it will be loading the content or storing the content with updations. Here it is not required, not operator, automatically it will write back. That we have seen from all the slides in the previous slides and all, on previous video also. Here where the offset is plus or minus 8-bit immediate data, keep in mind where we have specified in the addressing mode 2, it is a 12-bit number. The immediate data or immediate offset will be 12-bit number. Here where it is an 8-bit immediate number. So that we need to keep in mind here, especially for addressing mode 3 for half word or signed byte or signed half word. For this cases, what is the immediate offset will be 8-bit immediate offset will be given, or plus or minus RM. So H or SH or SB, what is this meaning called as? H is for half word, signed byte. So if it is not specified anything, obviously word access. What is the word access here? 32-bit. It will treat it as defaultly 32-bit only. If you are not specifying H, SH, this is the suffixes. If you are not specifying H, SH, SB, if you are not specifying, defaultly it will be performs a 32-bit operation only. So in the loading operation, load signed byte. So it is loading signed byte into a register, signed half word into a register, unsigned half word into a register can happen, but while storing, it is storing the half word. So there is no sign operation. Signed byte, signed half word will not be supported by the store instruction. It is performing only store half word. While loading, it can perform signed byte or half word can be performed. Okay. So let us move to the next slide by seeing an examples here. So let us see an example. LDRH. What is LDRH? Stands for load the register of half word. Half word stands for 16-bit data. Let us see what is this. This is pre-indexed form. Okay, what is the pre-indexed form here? The contents will be, the base and offset will be specified within the square brackets itself. Okay, so what is R1 here? 1018. This is the address location. So R1 plus what is the immediate data has been given? 02. So R1 plus 02. What is the R1 has been specified? 1819. So this is offset 0. This is offset 1. This is offset 2. This is offset 3. So here it is loading the contents. From where it is loading the contents? R1 is pointing to 18 plus 2. 18 plus 2 in the sense 1, 2. So it is taking from 1A. So what is the value it is there? It is, what is the simple meaning of this is called as, it is loading upper half word. upper 16 bit of 32-bit data is loading into R5. Repeating once again, LDRH is nothing but load half word. Which half word it is storing? If it is +2, it is storing the upper half word of the 16-bit, upper half word of the 32-bit, upper half word or upper 16-bit of the 32-bit will be loaded into the R5. That's what is the value of R5 here? 0x1234, but R1 will not be changed because there is no NOT operator. Okay, let us move to the next slide here. Next, LDRH R5 comma R1 comma 02. Here we'll come back here. That is already completed. Now see that LDRSH. What is that? SH stands for signed half word. What it is signed half word? The rest of the bits will be represented as signed. What is the sign? All ones will be there. That will be represented by all F's. Now what is the value of R2? R2 is nothing but it is pointing to 101C. So 101C. Okay, so what is that 0 indexed here? It is pointing to 1C plus 02. So this is 0 offset, this is 1, this is 2, this is 3. So it is pointing to C. So the upper 16 bit of 32 bit, what is the value here? ABCD will be loaded into the R5, but the most significant bits are all F's. All ones is nothing but FF. So what is that? Here the upper 16 bit will be loaded as lower 16 bit of R5. Repeating once again, R10 in the memory, it is upper 16 bit is loaded into lower 16 bit of R5. The rest of the bits will be represented as signed ones, which is called as FF. So that's what the meaning of this one. Load R5, signed R5. So the sign is indicated with all the ones, all F's will be there. Here there is no updations because there is no OR operator. R2 will not be changed. So let us move to the next slide. So let us move to the next slide here. LDRSB. What is LDRSB? What is the immediate data is 3. So R2 is pointing to C. Next is D. Next is E. Next is F. So this is 0. This is 1 offset. This is 2 offset. This is 3 offset. What is the value you will get here? It is nothing but AB you will get. So AB will be loaded into R5. The rest of the bits will be ones, which is called as signed ones. Okay, if it is not signed, it will be represented as zeros. Okay, so if it is signed, is nothing but all ones will be there. So it is called as FF. So how many F's are there? 6 F's followed by AB. So the upper 8 bit of 32 bit will be stored as lower 8 bit of R5 register. Okay, so I think you understood and you are following the instructions. Let us move to the next slide. So here STRH. Here in the previous cases, LDR, LDRSH, LDRSB, here that is not modified in the memory here, but here it is storing in R5. During that only how it is storing is called as loading. Now how it is storing in memory, it is affecting the memory here. Let us see an example of that one. STRH. What is the STRH? Store half word. Okay, where it is storing? In R2. R2 is a base register which contains it is storing R7. R7 is storing in R2, which is pointed by R2 register. What is the base register value? 101C. So here this is that A, B, C, D, E, F, G, EF and 01, which is of 32 bit of the R2 register. Okay, R2 which is pointing to the base register. Now after this instruction, it is storing the half word. Which half word it is storing here, which is pointing to here, it is nothing but, see here, it is storing in here, it is called as, what is the value of R7? 1. Okay, but we are storing half word, so this will be represented as 16 bit. What is the 16 bit? 0001. What is the 16 bit? 0001 will be loaded onto the 16 bit which is pointed by R2. So it is storing in C and D. The lower 16 bit it is storing here. Okay, if any immediate data has been given here +2, it will be stored in 0011 and EF and it will be stored here. But it is not specified any immediate data. So it is storing the lower order 16 bit of R2 base register. So which is called as 0011. After this instruction, this will be updated. So let us see in the one more example. What is the one more example? Here it is. Here two instructions str. Str, is there any suffix has been given? No. So defaultly it will be taken it as word. Word is nothing but it is a 32-bit instruction. So it is storing R6 content. What is the content here? 4. It is storing in R1. R1 is pointed to 1018. So what is that content here? It is nothing but 1018 is nothing but it is pointing to lower order 16-bit of 32-bit whereby R1 register. So R1 is pointing to 32-bit, but here str is nothing but what is there? It is storing all the content. Sorry, repeating once again ma. str is nothing but 32-bit. It is storing a word into a memory. Which content? The R6 content. What is the R6 content here? 4. So the 4 is stored in the memory which is pointed by R1. So the first step, it is storing all zeros, and 04 is stored into the memory. Okay. So after this instruction, it is taking store half word. Half word is nothing but R6 comma R1 comma hash 0x02. Here the immediate data has been given. So what is the immediate data? R1 plus 02. What is the R1 here? R1 is nothing but 1018. Okay, this is that 0 offset. This is first offset. This is second offset. So R1 is pointing to 1A. R1 is pointing to 1A. Now it is storing the R6 content. Where it is storing? Whenever it is pointing to 1A, it is storing the upper 16-bit of 32-bit. It is modifying here. So what is the resultant value? 0004 and 0004. The final value will be stored into the memory which is pointed by R1. Now, what did R1 value will be changed? No, there is no not operator. There is no write back. This is called as pre-indexed W equal to 0. Okay. So, before to this, I think you understood all these addressing mode 3. Half word, signed byte access. All these index instructions have been understood. So, let us conclude that by addressing mode 3. In the next coming up video, we will discuss the continuation of this. Okay, thank you. Okay, thank you all.